Hello and welcome to another daily coding problem. This is where I run through some technical interview question. Usually these come from LeetCode.com or dailycodingproblem.com, which is an email newsletter. They send you a problem every day and it says what company it came from and kind of an estimated difficulty. Today's problem did come from dailycodingproblem.com. This was asked by Microsoft. I'm gonna give myself up to half an hour to work on this. We'll probably be done a little quicker than that. Let's take a look at the problem. Compute the running median of a sequence of numbers. That is, given a stream of numbers, print out the median of the list so far on each new element. Recall that the median of an even number list is the average of the two middle numbers. For example, given the sequence 2, 1, 5, 7, 2, 0, 5, your algorithm should print out 2, 1.5, 2, 3.5, 2, 2, 2. Okay. So we're not calculating the median of all the numbers initially, right? We're calculating the median as we go. So on our first element, we only have one element, right? So our median must be 2. And then we go to our next element is a 1. So 2 plus 1 divided by 2 is 1.5, which is what we see here. Okay, that makes sense. And now we have our third element, and the median is the middle value once sorted, right? So this would actually be 1, 2, 5, and the median would be 2, which is what we see here. And let's do one more, just for the sake of clarity here. So now we have 2, 1, 5, 7, which if you put that in order is 1, 2, 5, 7. Which means the middle two numbers are 2 and 5. And 2 plus 5 is 7. 7 divided by 2 is 3.5. Okay, so that makes sense. So what I'm thinking about doing here is we'll grab our input and just walk through it from beginning to end one time. For each of those numbers, we will stick it into a sorted array and then print out the median of that sorted array. So that should be pretty straightforward, right? And actually, instead of printing, so that we can more easily write a test, this does say to print, but instead of doing that, I'm gonna return these values as an array. So we will be using a little bit more storage to do that, but we don't really care about that. I wanna test this, so I don't want to have to stub out puts or something. Capture it from standard out. I'd rather just return an array. So I'm gonna, instead of printing, I'm gonna return an array. Let's do that. I'm gonna grab this example they've given us and we'll use this for our test. And if this passes, then we know we're good to go. So let's open up our solution. We'll call this solution so we don't have to think about what to call our file. Solution test. This is going to be mini test auto run, which is what we use to run our tests. It comes with Ruby, we get it for free, we don't have to pay for it. And Minitest Pride there adds color to our output, so we get pretty reds and greens, and it'll say fabulous. And then we need to require the file we're testing, which we've called solution. And now we can describe what this file looks like. It's going to have one method that we're testing, which is called medians. Plural. Let's make it medians plural. Because this is actually going to return all medians. Return medians for each number in the input. Something like that. Let's paste our example. Okay, I lost it. Let's go back to our README. Copy this to our clipboard. Paste it in. Okay, so we've got this sequence. So this is gonna be solution.medians of this thing. And we wanna get back this. So let's add a comma after each of these. We'll go 5 down, repeat that. Then we'll close this, remove our last comma, make this an array. There we go. And this is what we expect to get back. And we'll indent that a little bit. Okay, Did we type this out correctly? Looks like we did. Okay, so we expect to get back our list of medians. Let's run our test. We would expect this to fail now because we don't actually have a solution yet. And that's what we see. Cannot load solution, so we'll create it. This is class solution. And let's create that method we're gonna test as well, which we've called medians, and that takes numbers. And let's run it again just to make sure everything's wired up correctly. Looks good. So we're expecting to get back our values here, and we're returning nil. So now we actually gotta do some work. So what did we say we wanted to do? We wanna go through each number, and for each of those, throw it into a sorted array, and then grab the median of that new sorted array and add that to our result, right? So let's make our result. We'll call it medians. It's an empty array, and then at the end, we'll return it. Let's create our sorted array. And now for each of our numbers, we will, so Ruby gives us actually a way to sort, right? We can just call, dot sort on an array, and that'll do it for us. But for a lot of these problems, I'm guessing they don't want us to use Ruby's built-in sorts, or, I bet Ruby even has a median function we can call, so we don't, or median method we can call, so we don't even need to write that. But let's write both just because I assume that we're going to need to do that. In the real world, though, we'd probably just use .sort and .median if that's a thing. So let's assume we have our method. Let's call it insert. This is going to be the method that we haven't yet written, but it's going to insert n into our sorted array. So we're gonna have to write that, right? What that's gonna do. That's gonna be, it's gonna insert it in a way that keeps it sorted. And we'll modify sorted in place for that. We don't need to return a new array. And then after that, we're going to get the median of our sorted array and push that onto our list of medians. And then return our medians. So that's good. Now we have to write these two methods though. So insert, this is going to be, what does it take? N and sorted? Perfect. This is going to be inserted n into sorted and keeping sorted sorted. So we don't have to resort it every time. So to do that, all we need to do is walk through sorted until we find an element that's greater than or equal to the one we're inserting, and then we'll stick it in at that point, right? So we can go from 0 to sorted.size. And I'm using the triple dot here, so it doesn't include sorted.size. If I only use 2 dots, it'd be equivalent to sorted.size minus 1, but we're gonna use triple dot here. And in that set of numbers, we want to find an I. We want to find an index where sorted of I is greater than or equal to the value that we're passing in. This index that we found is the point where we can insert n and keep our array sorted. So let's save that. So we're gonna save that to the value I. If we get to the end of our sorted array and we don't find an index, then we want to default to the end of the array. So we'll do sorted.size for that. So if this returns nil, then we'll go ahead and do sorted.size. And then after we've found that index, we'll insert it. So we'll do sorted.insert at I, the value n. So that may work. We may have a typo in there, may have made some kind of mistake, but let's assume that works for now. So we've got insert done. The next thing we want to do now, what do we have? Medians. Okay, so now we need to write this method here, which finds the median. And this takes in our list of sorted elements. And the first thing we want to do, I suppose, is find the middle index of this array. So we can do sorted.size divided by 2. That's going to be the middle. I'm going to add some spaces to center this a little bit here. Okay. And then once we have the middle, we have kind of two scenarios, right? If we have an odd number of elements in our sorted array, we just return the middle one. So if sorted.size.odd, we can return the middle element. Otherwise, if it's even, we have to average two numbers together, right? We have to average the two middle numbers. So that's going to be sorted middle plus sorted of middle minus 1, those middle two elements. And then that whole thing, we want to divide by 2, and we want to do .o, not just 2, so that it doesn't truncate our number. We want to do 2.0 so we get a decimal, because we know we're going to need to return decimals. So that's going to take our middle two values and average them. I think that's all we need to do. Is there anything else we need to do? I don't think so. I think that's it, right? So that's going to get the median. So we're going to insert into our sorted array while keeping it sorted, and then grab the median and insert into our medians array, and then return that at the end. Let's run this and see what happens. Sweet, it works. So I think we're at a point now where we could be done. But if you wanted to be clever, there's some more crap we can do in here. This reads pretty good, I think. We could put this on one line, then the line would be a little long. We could do a little trick in here, probably to get, I personally like if statements like this, even though we have a little bit of duplication. I think this is easy to read. You know, one way we could shorten this up would be to do, basically just to use this line here. And we could say sorted.middle plus sorted.middle minus, oh my goodness. And then, so this would be, let's see, sorted.size.odd. If it's odd, do a 2, do a 0, otherwise a 1. Hold on, wait for it. We're getting there. So this would be, I think, let's read this, make sure it makes sense. This would be another way to write it. So we can take our middle, we don't need to check, we don't need this if statement. We kind of still have an if statement, we just put it in line here. So if we have an odd number, then we'll add, then we'll just be adding the middle number together twice and multiplying by 2. Let's try running this and see what happens. Okay, so this does work. I don't like how this reads though, but that does seem like a very Ruby thing. Okay, this looks great to me. Let's check our tests, see if there's anything else we want to add in here. Let's add, you know, let's add with one number, just to make sure. So we'll stick a 2, just a 2 in here. Let's run that. Okay, that looks good. Let's try an empty as well, just to see if we should handle that. Okay, that works. I think we're good. Let's throw this into a commit and push it on up. There's our solution. Our solution still has all those empty lines at the end. Let's remove those. There we go. Okay, that looks better, and our tests looks good. So we're gonna add a solution for today, which is the 5th, right? Okay, pushed it on up. That's it. So that took us about 15 minutes. That seems to be about how long we were taking with these problems now. Thanks for joining me. We'll do another one of these tomorrow probably, if not the day after. I've been taking the weekends off though, but today's Thursday, so I still got one more day. I'll see you then. Thanks for joining me. Bye.